To determine whether or not your topic will make a good Molmodac topic, you can use the checkpoint questions, which are available under the topic selection page, which is part of the checkpoints and deadlines section of the Molmodac wiki. If your topic doesn't pass one of the checkpoint questions, this should be a red flag that it's probably not suitable for the Molmodac project. But let's go through these checkpoint questions one by one to get a feel for what we're looking for out of a topic. In addition, we expect you to answer these questions and place answers on your Molmodac page in the Scratchpad section before the preliminary topic selection checkpoint. So the first question says, is the compound's behavior well known to the general public? But are the details of the compound's mechanism of action not well known? A good example is Dr. Moore's example of why is salmon pink. So everyone knows that salmon is pink, but few know the molecular origin of that effect. The second question is, has another group already selected this topic? If you haven't already, please add your key literature reference to the primary literature collection for your topic, and when you do, look for another group that's chosen the same reference. You can claim a topic using the primary literature collection by adding an entry to the table and adding your team's name to the right-hand side. But make sure that another group hasn't already selected your topic of interest for this semester. The third question says, is the molecular mode of action understood at the level of bonds and atoms that we see in organic chemistry? This means that we're looking for more than a biological explanation, for instance, of an effect that happens in the human body. Biological explanations operate on the supramolecular level, which is too large to really be beneficial to us and too large to really tap into the knowledge of organic chemistry that you'll gain from 332. And so you'll want to look for mechanisms that involve bonds and atoms. This doesn't mean that the mechanisms won't involve large molecules necessarily, like proteins, nucleic acids, and other macromolecular compounds. But what it does mean is that the particular events that dictate the effect should be at the molecular level. For instance, the action should be taking place in the active site of a protein, which is small enough that it can be represented by only a few bonds and atoms. The fourth question, which is somewhat related to that, says, can you use concepts, vocabulary, and principles from 232 and 332 to explain the molecular mode of action? So, mechanisms that deal with topics that we don't touch on or that aren't organic in nature, you'll want to avoid. And while you're examining, for instance, the literature for a potential topic, you'll want to think about how it relates to the content of 232 and 332. The primary literature collection includes a column that mentions some lessons that are relevant to each literature reference provided there. The fifth question says, does the mode of action involve covalent bond changes, or is the mechanism based entirely on non-covalent interactions like hydrogen bonding and ion dipole interactions? We'd like to see mechanisms that involve covalent bond changes because these allow you to tap into things like curved arrows, mechanistic principles, and things like this. This doesn't mean that your topic has to exclusively involve covalent bond changes, but you'll set yourself up for maximum success if you find a mechanism that does. The sixth question is, are primary literature references available that give experimental evidence for the mode of action? And naturally, I think the way we've built the project, you'll find literature references that are relevant to your topic. But if you don't, that's definitely a red flag that the topic is unsuitable for Molmodac, because you'll need to explain a mechanism from the literature on your wiki page, and without that literature basis, you won't be able to do that. The seventh question is, can you find structural files that provide the atomic details of the relevant molecular components, such as proteins or small molecules? Are these based on reliable experimental data like X-ray diffraction, or computational data, which is okay as well? And can you construct reliable structures from computational models? So a lot of good Molmodac projects, not necessarily all of them, revolve around compounds that have been characterized structurally through X-ray diffraction or other techniques. What this allows you to do is to use the structure as evidence to build an argument for the mechanism. Arguments can be built in a variety of ways, and using structural aspects, visualizations, is only one way of doing this. And so it's not essential for a Molmodac topic that structural files be available. However, it can provide you with an advantage and just another angle of attack to explain or support a mechanism that's been proposed in the literature. And then the final question says, what fundamental questions or problems can you identify in the literature associated with your topic? And so these will form potentially the basis of challenges that you'll place on your wiki page. Challenges are listed under the mechanism of action section, and so you're looking for the fundamental problems associated with proposed mechanisms for the topic. So how is it known? What experiments were done to pin down a particular mechanism, for instance? What are the stereochemical aspects? What are the electronic aspects of a particular mechanism? These are the sorts of questions that you want to think about to answer this final checkpoint question. So if your topic meets all of these checkpoint questions, then it's a great potential Molmodac topic.